Hey everyone, welcome back. Today we are diving into something absolutely fascinating. We're looking at the actual physical core of how our minds operate, the architecture and utility of the basal ganglia. Look, if you're the kind of person who loves geeking out over the hidden mechanics behind our everyday actions, well, you're in the exact right place. Let's get right into it. So, I want to start by asking, how much of your habits, your movements, those seemingly spontaneous decisions you make, how much of that is literally just a byproduct of your brain's physical wiring? I mean, think about the last time you drove a super familiar route home and then suddenly realized you totally zoned out for the last 5 miles, right? We love to think of ourselves as these completely free agents, kind of just floating above our biology. But as we unpack this material today, you're going to see that the physical connections inside your head are absolutely running the show. And we're about to explore the exact structure that perfectly embodies this. All right, section 1, let's meet the basal ganglia, our core subject for today. Now, as you probably already know, the basal ganglia is not just some single lump of tissue. It's this beautiful cluster of interconnected nuclei tucked way down deep beneath the cerebral cortex. We're talking about crucial players here, like the striatum and the globus pallidus. Our source material today really cuts through the noise and zooms in on two main pillars, the physical connections and the resulting functions. It's kind of like looking at a master blueprint for some incredibly advanced tech. You literally cannot understand what the machine does until you trace out exactly how the wires are plugged in. And that's exactly what we're doing today. We're treating the basal ganglia less like a static piece of anatomy and way more like this absolute marvel of biological engineering. Moving on to section 2, mapping the neural connections. The architecture. Okay, so a great way to visualize the basal ganglia is to think of it as this massive biological switchboard. On the input side, you've got an unimaginably massive amount of data just pouring in from the cerebral cortex. We're talking everything from raw sensory inputs to really complex motor plans. The architecture of the basal ganglia takes in all of that incredibly chaotic messaging. But, and here's the cool part, what comes out the other side isn't chaos at all. It's this highly refined, super specific neural output that gets routed right back up through the thalamus. It's essentially the ultimate filtering system. Its architecture is explicitly designed to take a wide funnel of inputs and just distill them all down into one precise, targeted response. Let's actually trace that journey step by step. Step 1, the input signals arrive. Millions of data points just bombard the structure. Then, step 2, the architecture routes the signals. And guys, this is where the magic really happens. Imagine your phone buzzes on your desk. Your basal ganglia has to actively route the decision to reach for it. It sends excitatory signals through the direct pathway to initiate the movement, while literally at the exact same time sending inhibitory signals through the indirect pathway to suppress the urge to just keep your hands still. It's a completely dynamic routing process based 100% on its structural wiring. And finally, step 3, the output connections fire. The decision is made and the signal shoots back out to the rest of the brain to be executed. If this routing architecture is tweaked even a tiny bit, the whole output changes. The connections really are everything here. Which brings us to section 3, functions, the brain's utility. So the absolute crux of our explainer today is that the functions of the basal ganglia are derived directly from that neural architecture we just mapped out. Because it's wired to selectively route outputs, it basically acts as the ultimate gatekeeper of your behavior. We're talking about massive critical utilities here, like action selection, choosing one specific movement over dozens of competing ones. We're also talking about procedural learning, think muscle memory, and habit formation. Honestly, without this precise architecture, you wouldn't even be able to automate something as basic as tying your shoes. Every single habitual routine you fall into relies entirely on the utility provided by this highly specific setup. And seeing how the physical routing translates directly into behavioral execution is just mind-blowing. Take dopamine, for example. When a dopamine signal from the midbrain gets routed through this architecture, it doesn't just passively drift through, it chemically reinforces the pathway itself. That pure physical routing of a neurotransmitter leads directly to the functional utility of reward-seeking and building habits. You simply cannot separate the physical connections from the behavior that follows. The architecture is the utility. The physical form of your brain dictates exactly how it functions in your daily life. It really is just a beautifully efficient system. All right, section 4, the final takeaway. Form follows function. So the big takeaway here is that the architecture of the basal ganglia's connections defines its ultimate utility and functions. We've taken a pretty deep look at a fundamental biological truth today. The brain isn't magic, right? It's mechanics. And to really grasp the stakes here, you just have to look at what happens when this architecture degrades. In conditions like Parkinson's disease, the specific dopamine-producing cells that feed into the basal ganglia actually begin to die off. The physical form is compromised, and as a direct result of that, the utility degrades right along with it, which leads to a profound loss of motor control. The basal ganglia's ability to provide us with all this immense utility is completely dependent on its incredibly complex, precise architecture. Form and function are just inextricably linked. I want to leave you with one final thought, kind of circling back to where we started today. If your actions, your habits, and your everyday functions are strictly governed by these internal physical connections, well, how much of your behavior is just architecture? It's kind of a wild perspective shift, isn't it? As you go about your day-to-day and you automatically navigate your commute or reach for that cup of coffee without thinking, just remember that incredible neural switchboard working silently behind the scenes to make it all happen. Thank you so much for hanging out with me for this explainer. I really hope this structured look at the basal ganglia sparked some curiosity for you. Until next time, keep questioning, keep learning, and I'll catch you in the next one.